All right, well, Zach and Rebecca and Everett, I have 2 people left, and we are going to be finishing up some stuff today. Don't forget, you do have an exam coming up on Tuesday. Okay, so exam coming up Tuesday. So nothing we cover today is going to be brand new, but there are a couple things we're going to cover toward the end of the lesson today that are going to be new for this year. Okay, so Kyla will remember these things. Curtis, I didn't have you before, so I don't know if you would recognize these things. So therefore, Everett would be in the same boat. Rebecca and Zach, these are things we're going to review from what we talked about last year in pre-algebra. We're going to start with some other reviews. Start on page 142 in your textbooks. Page 142 in your textbooks. And very quickly at the top of the page, I want you to do numbers 1, 3, and 5. Number 1, number 3, number 5. Finding equations of lines given a slope and a y-intercept, given a slope and a point, given a couple of points. So page 142, 1, 3, and 5. Quick review. This is stuff we'll have to do on the exam, so a little bit of exam review right now. But just make sure we keep some things sharp. In case you're wondering what is wrong with my chalkboard, why it is so messy, Emma happened. Okay, my daughter's to blame too. Renee was involved, but we're going to mainly blame Emma because she's the one who had the idea to write on the board and mess it up, so it's not beautiful. Yeah. slope on the last one correct?
I did 4 negative 3. I forgot to put minus.
Forgot the negative. So you had 1/5 as the slope?
No, I had 1.
You also had 3 negative 2 instead of 3 minus negative 2. Okay, yeah, be careful. Make sure we subtract. In which case, when we're subtracting negatives, it's adding the inverse. All right. So that would throw that answer off. Zechariah's like, yeah, I had that. Yeah. Crumples his paper up, throws it away. Recopies everything. Everett's like, I had it done before you did, Mr. Dasky. I mean, I paused the video, so I'd win, but still, I mean, I beat you. Some people's kids. It's your little brother, I mean. Yeah. Did I call her? You know we did that too, don't you? Yeah. Kyle's like, nope. All right, how about the first two, Kyle? You good on the first two?
Yes.
Okay, but like Curtis ran into some trouble on the last one. Now his problem was he forgot it was minus, so he just put 4 negative 3, 3 negative 2, got 1 over 1. So we're a slope of 1. So that threw everything off for him. What was your slope?
I had 7/5.
So you're good on the 7/5. When you plugged it in, did you use the 3, 4 or the negative 2, negative 3?
I used the 3, 4.
Okay, did you put the 4 in the y spot?
Yes.
And the 3 in the x spot? So this did give you a 21/5. So like this level was good. 4 equals 21/5 plus b?
I see what I did. I don't know why. I just didn't multiply the middle, and I went to do multiply everything by 5. Like in the middle, I did them each by themselves.
Oh,
Yeah.
okay.
I skipped
So you ended up with like a
step.
really big number right here.
Yeah, I got
105?
Yeah, and I got b equals negative 17.
Alrighty then. Does it make sense now what you should have did?
Yes.
Alright. So let's take a look then at numbers 7 through 10. And this is what we've been working on more recently, solving inequalities. You don't necessarily need to graph the solutions, just solve the inequalities doing 7 through 10 now. Okay, this is what we had our quiz on a couple days ago. So you should be pretty good with this here. Let's just make sure. Curtis is good to go. And Kyle is good to go as well. Excellent. Now again, what I did, I avoided having to ever divide by negatives right here, getting rid of the little x. Now it left me the x on this side, but I didn't have to divide by a negative, so I didn't have to think through the flip the inequality around. Same thing over here. I avoided the negative x. I avoid the negative x. If I couldn't avoid the negative x for some reason, if this had just said negative 3x negative 6 is greater than or equal to negative 9. If I just had to deal with the negative, well then class, I would have to, if I had to divide the negative, flip the inequality, get a, and there's your, and it's the same answer this way. Or we might be saying, remember, well, couldn't I just change all the signs? Yes, but when you change all the signs, this is one of them that would need to be changed as well. Okay, so again, generally we try to avoid having to divide the negative, and getting rid of the little x will help you with that, but I want to make sure I showed that as well. Flip back to page 141 in your textbooks. Flip back to page 141, the previous page. We worked on some of these word problems involving inequalities yesterday. Let's take a look at page 141. Read problem 8 nice and loud so the camera can hear you, just in case somebody like, I don't know, Everett doesn't have his book. Curtis, help out little bro. Problem number 8.
Brent cuts grass for $30 per yard. How many yards would he need to cut in a day to earn at least $200?
I don't know, it seems like, number one, $30 doesn't seem like very much anymore. Back when the book was originally published, I don't remember what year that was, but I feel like it was like 2012, so I feel like it's over 10 years ago. $30 a yard was okay pay for a teenage guy, but 7 yards in a day, wow, that's a tall ask. He'd be really tired. Anyway, the question is, how many yards does he need to cut? We don't know how many yards, class, so let's call it X. But we know for every yard he does cut, he gets paid $30. And he wants to make it says at least 200. At least means? Greater than or equal to. So what do we need to do? How do we need to set this up, Kyla?
30x is greater than or equal to 200.
There we go. And technically I need to do what next, class? Divide away the 30. But really, truly, I'm lazy. I don't want to divide by a 30. Let's knock off a couple of zeros, and let's just make it 20 divided by 3. How many times does 3 go into 20? 6 with 2 left over, so we could make it 6 2/3. He needs to cut at least 6 2/3 yards. Thoughts?
Shouldn't just cut 2/3 of the yard.
We're going to have a really unhappy customer because, now I will say, there was one time I had a customer who hadn't mowed their yard in a very long time, and then they asked me to mow their lawn. And my lawnmower got bogged down. The grass was so thick, it couldn't get through it, and it died halfway through their backyard. And I had to stop, get the lawnmower fixed, and come back the next day. Okay, so maybe that's what happens, but probably we don't want a customer being left with 2/3 of the mown lawn. And so, what do we need to do here, Curtis? Round it up to 7. Do we round it up to 7 because 2/3 is greater than half? How do we determine how to round in an inequality?
It says at least greater than or equal.
So greater than or equal to always rounds up. If it said less than or equal to, even though it's a 2/3, we would still round down. We would round down. Even if it said greater than 2/3, if it said less than or equal to, you round down. So greater than round up, less than round anything down. And so we're going to say he needs to mow or take care of at least, class, 7 yards. 7 yards. Does that make sense? Questions on that one? Look at numero 10. Read that nice and loud for us, Kyla.
Freight elevator's maximum load is 4,500 pounds. If 2 workers weigh 170 pounds and 185 pounds, and the cart they use weighs 90 pounds, how many 50-pound boxes can they safely move on the elevator in one trip?
Yeah, I went to college at PCC, and a lot of their buildings are tall instead of wide. So like you look at like Columbus Tech, they don't really have any tall buildings. Even CSU doesn't really have any tall buildings. PCC has tall buildings. So kids want to use elevators because they don't want to go up, 4, 5, 6 flights of stairs to get to class. And so they packed the elevators with as many kids as they could hold. And there was a little warning buzzer that would go off if you had too many kids in the elevator. And so usually what it'd be is everybody cram in there, and if the buzzer went off, the last one on had to get off. and then right as the doors are closing, jump back in and still see if they can make it up. Anyway, they weren't supposed to do that, but you know what it is. Well, I remember at one point I worked for the campus store, so we sold all the textbooks to students and supplies that they needed, well, including nursing supplies. And the nursing floor, I think it was 3rd or 4th floor of the academic building, and you know, we're not going to carry 60, 70, 80 boxes up the stairs, so we loaded up on a cart, and we tried to fit the cart into the elevator, which was not intended for freight. You know, it's got this, you know, nice tile floor and glass sides and lights and all that cool stuff. Anyway, so we loaded in there. So I'm picturing me and my coworker with the cart loaded with boxes trying to fit in this elevator, and we don't want the buzzer to go off. So that's where we're at here. Maximum load is 4,500 pounds. Maximum meaning, class?
Equal to,
Less than or equal to, right? You don't go over that number. Under's fine, but not over. So less than or equal to. So whatever we put on the elevator, whatever this load is, has to be, class.
Less than 4,500.
There we go. All right, so what are we putting on this elevator? What is this elevator supposed to carry?
170 pound man,
170 pound person.
185 pound person, a 90 pound cart, and 50x amount of boxes.
Good, 50x. However many boxes we don't know, but since everyone weighs 50 pounds, 50x. All right, good. Kyla, Curtis, were you thinking the same thing? And Zach is like, I am now. All right, so at your seats, let's go ahead and start by combining all of these other numbers together. What do we get when we combine all those other numbers?
245. No. I don't know what I did. Oh, I
495.
445.
I have 445.
I did that. I didn't.
Yes, Rebecca says 445. We can trust her. All right, so it adds up to 445. What do I do with the 445? No, don't add 50 to it.
Oh, no. Subtract.
Subtract it to the other side is a negative 445 to get, let's see, 50x is less than or equal to, good Rebecca, 4,055. All right. And then class, we need to divide everything by 50. Oh, that's going to be annoying, isn't it? Off to the side. Let's do our long division. How many times 5 go into 40?
8.
8 times. 8 times nothing? Don't make this too hard now.
0.
Nothing. And 8 times 5?
40.
So we have,
5 left over.
bring down the 5. How many times 50 go into 55?
1.
Once with
5.
5 left over. If we add a decimal, we can bring it down. How many times 50 go into 50?
1.
So, they have to have less than or equal to, no more than, how many boxes, class? 81.1. Thoughts?
1 is more than.
Yeah, that 0.1 box, you know, have a box that's a tenth full. No, they're probably not having boxes. So, let's say we round to 81. Since it's a less than, even if this had been a 0.9, we would still round down because it's maximum load. No more than, less than or equal to. For the 1, we would round down anyway, so we'll say no more than 81 of these boxes. All right, questions on that problem? We'll look at problem 11 and read that for us, Curtis.
Miss Mount Calvary there. How do you say it?
Mount Calvary?
Oh. Calvary's
One
budget
spiritual statistic.
for a swing set and play fort to be built for the children's church is $900. If the cost of the swing set should be at least 1/4 as much as the fort, how much can be spent on the fort and still build a swing set?
All right, at your seat, set this one up. Mount Calvary, which is some kind of church, apparently has want to build something for the children's ministry. Build a play fort, build a swing set. The play fort's the main attraction. They want to add a swing set to the side. Their budget's $900. What does it mean if the budget is $900?
Less than or equal to.
They want to spend less than or equal to that much, right? They know that the swing set is going to be 1/4 as much as the fort itself. So how much can they spend on the fort and still have enough left over for the swing set? unknowns, class?
Swing set and fort.
Which one gets to be x?
Fort.
Fort. How do we represent the swing set?
900 minus x.
Oh, we could go total minus x. That wasn't where I was going to go with it, but that would work technically. What were you going to say, Kyla?
1/4 x.
I was going to say a fourth x. Now, we can look at this two different ways. Let's look at it both ways. If we go from, let's go with Curtis's perspective first. If we say the total is going to be 900 at most, 900 minus x, and this is going to be x. Well, it said that the swing set, 900 minus x, should be, or class, at least, meaning
greater than or equal
a fourth of the fort. And that would be your equation, Curtis. Is that what you had? Okay. Now, Kyla, if we go from your perspective, the swing set's going to cost a fourth of the fort, and the budget is 900. What was your equation?
X plus 1/4 x is less than or equal to 900.
Now, I want you to notice something. If I were to move the x over as a negative, then this would be that 900 negative x is greater than or equal to a fourth x. It's the same equation he's got. You technically have the same one. It just depends on the way you think of it. This is actually more the way I would tend to think of it. But there's nothing wrong with the way you approached it either. So both of you, as you solve, well, probably we want to get rid of the... I would like to get rid of the denominator, right? I like to knock out the fraction, multiply everything by 4. 4x plus x is less than or equal to... What's 4 times 900?
Oh, sorry, I thought you were
I mean, yes, it does combine to give me 5x. Very good.
3,600?
There we go, 3,600. Now, the nice thing is, the way Kyla approached it, the x's were already together and combined easily. Curtis, you're going to get to the same point when you multiply everything by 4, right? You get the same 3,600, but you'll have a negative 4x greater than or equal to x, and you'll have to move the x over to get the 5x. Hers were already together, but again, it doesn't make one right, one wrong. They're both correct ways of thinking. And we divide both sides by 5 either way, and the amount spent on the fort needs to be less than or equal to $720. There we go. All right, so the fort needs to be less than or equal to maximum $720, which means the swing set will be at least minimum how much?
$180.
Swing set can cost up to $720. The fort costs up to $720 because the swing set's going to cost at least $180. And there's our answer. Questions on that? All right, let's turn over to page 144 now and review over some things we looked at yesterday. Compound. Well, came out garbled from all that singing I've been doing lately. No, I'm just kidding. All right. They've been singing, and we're praying for you as you sing now, though you'll not watch this till after you've sung. Hopefully you did well by the time you watch this. Page 144, we were working on compound inequalities, where there's not just a, hey, it's got to be at least this big, this much or bigger. I could go to infinity, right? That could be a little unrealistic. Or this much or smaller, or less than this, or greater than this. But how about between these two limits, right? You're like, maybe going into the algebra exam, you're like, well, I can't score higher than 100, and that would be really nice to get on the Wall of Fame, which is filling up rapidly now. But I want to go no more than 100, obviously, but I really want to get at least a 90. I want that A, because if we all get A's and donuts and whatnot. So we want to score between a 90 and 100. There's a lower limit and upper limit. That's the idea of the compound inequality. Well, as we look at these compound inequalities, looking at problem number 3 on page 144, they say that negative 6 is less than 3x is less than 9. Notice, by the way, the progression. The smallest value, the lower limit, is always first. The biggest value, the upper limit, is always at the top. And the value at the x should be in the middle. But it really should just be x. And it's not. It's 3x. So we got to get rid of the 3, class. Divide away. But what I do to one part, I have to do to all the parts. So as opposed to one side and the other side, there's now 3 places to do stuff. And what's our answer going to be?
X less than
Good. X needs to be greater than the -2, but less than the 3. So we would say -2 is less than x is less than 3. On the number line, well, anytime we have a less than or greater than symbol, no or equal to, we said we're going to graph it with a open dot. And then we'll shade everything in between them. And there's our values. Do you remember doing this yesterday? All right. Look at number 5. Number 5, what do we have to do to get the x by itself on number 5, Curtis?
Turn -1 to positive and add it on every side.
Yeah, put a +1 every single place in the inequality. And so we add 1, add 1, add 1, that cancels, and we end up getting?
2 is less than x, less than 3.
Now this graph is really kind of sad looking because we have to do what to graph this, Curtis?
Put open dots at 2 and 3
And shade everything?
in the middle.
Not including 2 and 3, by the way. So our graph is basically 2 point something. Can't get to 3, and it can't be 2. So as long as it's 2 point and there's something after the decimal, it's in that range. Nothing else is. It's a very small range. Let's see, number 7. We have to do 2 things on number 7 to get the x by itself. First of all, Kyla, we need to
Take away the 5, so add it to all of those.
add the 5 everywhere. And you could cheat and say, well, I know I'm adding 5 here, so instead of writing, I'll just cross it out. But I'll put the +5s here to get
0 less than 3x less than 9.
and then we,
Divided 3.
and again, if you wanted to do this even in your head, you could, just be careful. Here we get
0 less than 1x less than 3.
there we go. And when we go to graph this, what would we do?
Put an open circle on 0, and an open circle, also a circle, sorry. Put on 3, and then fill in between.
The open dot or circle on 0 and 3, and then shade in between. So anything 1, 2, anything 0 point something, 1 point something, 2 point something, all of those values would work. Now, they didn't give us any of these work. Let's just say, for sake of illustration, this had been less than or equal to 4, less than or equal to 9 then when you add the 5, less than or equal to 3 when you divide away the 3. What's the only difference to the graph now, Curtis?
3 is a closed dot.
3 is now a closed dot, a solid dot on the 3. And that's all we would do differently there. Questions on number 7. Number 9. Ooh, what do I need to do first, Curtis?
Undistributed.
The
2.
There we go. Inside the inner part of the inequality, we need to distribute the 2 to get
2x -2.
There we go. And now that we've distributed the 2, now we go ahead through our next 2 steps. So it's going to take 3 steps to solve first, or second technically. First was distribute, second.
Add a +2 to every side. To get -1 is less than or equal to x.
Well, 2x.
2x. 2x, and it's less or equal to 4.
All right, and then?
You divide away the 2 from x. And you get -1/2 is less than or equal to x, less than or equal to 2.
Perfect. -1/2 is less than or equal to x is less than or equal to 2. Now, when we go to graph this one, again, it's not, and graph paper probably would have been a smart thing, but anyway, our -1/2, where is that?
Between the 1 and 0.
Between the 1?
-1.
Okay, between the -1 and 0. So right here, and it's going to be a solid dot this time, isn't it? So a solid dot right in between there. The other solid dot goes on 2, because they're both, or equal to. So then we just shade in between, darken that segment in between those dots. And there we go. Do we remember doing this yesterday? Any questions at all on this? Drop down, if you would, to number 19. So same page, but on page 144. Drop down to number 19. What does it look like we're going to have to do to get x by itself on something like 19, Kyla?
Multiply by 3.
multiply everything by 3. You've got an x over 3. You've got that fraction. I hate fractions. Let's get rid of it. Multiply everything by 3. When I do, Kyle, I think we can get this in our head. What do we get?
15 is...
Careful.
Negative 15 is less than x is less than or equal to 21.
Now, I don't know that I'm planning on graphing this necessarily, but in theory, if I did, Kyla, we would put a circle on negative 15. You could say open dot. That's fine. Open dot or circle, either one.
And a closed dot.
There we go. That's 36 little tick marks later, so that's why we're not actually graphing. And we, of course, we would shade everything in between them. Looking at number 21. This one's going to take a couple steps. The first thing we do on 21, Curtis. Good. Multiply everything by the 5. And what do I get?
You get negative 5 is less than or equal to x plus 1 less than or equal to positive 5.
And then my final step.
You subtract 1 on each side.
To get?
Negative 6 is less than or equal to x less than or equal to positive 4.
This one wouldn't be too bad to graph, but again, for sake of time, we'll just talk it through. Put a
close dot on negative 6, and then put a close dot on 4, positive 4.
And
then
shade in between. Very good. Look at number 23. Kyla, this one's going to take 3 steps. Negative 7 is less than or equal to 4x negative 1/3. What is less than or equal to 5? What do we do?
Multiply everything by 3.
To get?
Negative 21 less than or equal to 4x minus 1 less than or equal to 15.
There we go. Then?
Add 1 to each side.
And what do we get?
Negative 20 less than or equal to 4x less than or equal to 16.
And then finally?
Divide everything by 4.
To get?
5. Negative 5 is less than or equal to x less than or equal to 4.
And then we're going to put a
closed dot on negative 5 and a closed dot on 4.
And
shade everything in the middle.
There we go. Feel pretty good about those? Let me have you do numbers 20, 22, and 24 at your seats. 20, 22, 24. We're not going to take the time to actually graph them. I think we've got a good understanding, so we'll be lazy. I think you could do it just fine if you needed to on the exam, so. All right, number 20. We had to multiply everything by 2 to get what for our answer, Kyla?
4 is less than or equal to x less than 6.
Good. 4 is less than or equal to x is less than 6, so close dot on 4, open dot or circle on 6, and shade a little bit of space in between them. Number 22, had to multiply the 4 and add the 3 to get what for your answer here, Curtis?
Negative 5 is less than or equal to x less than or equal to 7.
Excellent. Negative 5 is less than or equal to x less than or equal to 7. Number 24, we had to multiply the 4, subtract the 1, divide by 3. We did all 3 of those steps. Kyla, what did you get?
Negative 3 less than x less than 5.
One little edit.
Is it positive 3?
No. Curtis?
It's less than or equal
Less than or equal to. You just lost your or equal to's. Yeah, so negative 3 is less than or equal to x, is less than or equal to 5. Otherwise, great job on that. Look at number 12, if you would, please, though. This is where things get a little bit dicey, and this is the most important part of the video. Okay, so if you've been sleeping till now, Everett, go ahead and start watching. Maybe I'll tell Mom, wake him up at 35 minutes and 45 seconds. All right, so anyway, number 12, we've got this really basic inequality. It looks like 4 is less than negative x is less than 7. There's just one problem. You can't have a negative x, right? We're not solving for negative x. And remember, if we had something like, I don't know, 2x minus 3x is equal to 8, we would combine to get negative x equals 8. And then I said, do what, class? Change the signs, right? Because we don't solve for negative x, we solve for positive x. We know what I need to do here? Change the signs. So instead of a negative x right here, make it a positive x. And change the signs. But remember, when you change the signs, these are also signs that need to change. So you end up getting negative 4 is greater than x is greater than negative 7. There's only one problem with this. As you picture the number line, here's negative 4, relative to 0, here's negative 4, negative 7's down here, right? These two numbers are not in the order they appear on the number line. Also, we don't want greater than symbols. We always want the symbols progressively getting larger because we want to work with smaller number going toward larger number. So what we need to do is we change the signs. That changes these also. And then we take the whole thing and flip it around. So that the negative 7 comes over here. The less than still points at the negative 7. The mouth still opens to the x. This point still points at the x, and the mouth still opens to the negative 4. You see, we just take the whole thing and flip it. Now, you should remember this from last year in pre-algebra. Do you remember seeing anything like this before? Sort of, kind of. All right, we can do this as well if we look at problem number 14. Number 14. Now, we're not ready to change all the signs yet because we don't even have the x by itself yet. So let's start here by getting rid of what, Curtis? Everett? Yeah, we already got rid of him. Now what do we do? Sorry, Everett. We don't really hate you. We just act like we do. All right, go ahead.
Change negative 2 to a positive and add x.
Good. Put a positive 2 everywhere to get?
5 less than negative x less than 7.
Well, we've got add the 2 there also, remember.
Oops, 9.
9. Just making sure I didn't copy it wrong. All right. And now it's just a plain old negative x. So now I got to do what?
Change the sign.
All the signs, right? So that this becomes a negative 5, this becomes a greater than, this becomes the positive x, this becomes a greater than, this becomes a negative 9. Do we all get the whole idea of changing all the signs? And that includes the inequality symbols. Okay, so now for our final answer, we've got to flip the whole thing around. And Curtis, what's it going to look like if I flip the whole thing?
Negative 9 less than x less than negative 5.
There we go. Now, there is one thing I want to point out. Let's suppose, hypothetically, this is the correct answer. Let's suppose this had been a less than or equal to. Then right here, this would still be less than or equal to, right? Which means right here, this would have been greater than or equal to. When you flip the whole thing around, do you see that this greater than or equal to is opening to the negative 5? It would come here. Does that make sense? It's not so much a matter of bringing it straight down until the whole flip happens. And then you make sure this stays between the x and the negative 5, and the mouth continues to eat the negative 5. Does that make sense? And that's something we saw last year as well. But just want to make sure I pointed it out since they went with matching signs both times. Look at number 16. Number 16, we've got a 0 is less than 2, negative x is less than 5. Kyla, talk us through this problem.
Add 2.
There we go. We don't want lots of x's everywhere.
To all the sides.
Works for relationships too. Anyway.
Negative 2.
Gonna put negative 2 everywhere to get?
Negative 2 less than negative x less than 3.
There we go. All right. There's a little heart there with your negative x.
Make the negative 2 a positive 2 less than, or greater.
Everything changes, right? So make this a
x greater than negative.
There we go. Every single sign changes. And then we flip the whole thing around. There's no more love, by the way.
Negative 3 less than x less than 2.
There we go. And there's our answer. Curtis, you got it? Tracking with us? All right, last one we'll look at, and then I'll have you try some of these on your own. Number 18. We've got a negative 3 is less than negative 4x plus 1 is less than 9. I'm going to make this a less than or equal to 9. If you'll make that change on your paper as well. So we're going to modify number 18 just a little bit, make that a less than or equal to 9 at the very end of the problem. All right, Curtis, first things first, what doth we? What doth we do with forsooth?
Subtract 1 from
To get?
negative 4 is less than negative 4x less than or equal to positive 8.
Good, all right. Then what, Kyla?
Divide all of it by negative 4.
Good, divide everything by negative 4. But when you divide by a negative, class, you gotta flip the inequality. So here, Kyla, I get
1
positive 1. But because I divided by a negative, I gotta flip this inequality.
greater than x, which is greater than equal to 2. Negative 2.
There we go. So if you're just changing all the signs, you have to change the inequalities. If you divide by a negative, you have to flip the inequalities as well. Okay, so do we see we do that with regular inequalities, we do that with compound inequalities, but we don't want to leave our answer this way. So how do I write the answer instead? Curtis?
Negative 2 less than x less than or equal to.
Ah, careful. The one that's associated with the negative 2 is the one that has the equal to in it. So that one comes over here. Does that make sense? The point of the less than or greater than or equal to needs to be aiming at the negative 2. So it becomes a less than or equal to aiming at the negative 2 still.
X less than 1.
There we go. And that symbol stays there. Does that make sense when you see? It's almost as if, imagine this were a glass board. You ever seen a glass board where you can see from both sides, but one side's backwards? Imagine this is a glass board, and you were on the back side somehow, and you were looking through it. This is what you would see. Negative 2 is less than or equal to x is less than 1. If you're seeing through the board that way. That's kind of what we're doing. Does that make sense? All right, your turn to try 11 to 17, the odd. 11 to 17, the odd. 11, 13, 15, 17. Let's see if we got this. I should wake you up. Stuck or checking?
Checking.
Checking, okay. You are finished then?
Mm-hmm.
Okay. Trying to read facial expression. I wasn't coming up with anything there. I could see it was spray tan. Just kidding. Did we get them all? I got a thumbs up from Curtis.
I don't know what I did on the last one.
Okay. Check your first step. Did you put the -5 everywhere to get a -14?
Yeah. No.
What did you have right here?
I had +14, but I knew it was -14.
Okay. All right. Yeah, that could really mess things up because then the numbers are at the end aren't going to be in your alphabetical order, right? You would have, or numerical order. You would have had your -7 over here, and like -3/2 shouldn't be on that side of -7. Is that right? Did you end up with a -7 right here?
I don't know what I ended up with. I have a 2.
You have a 2. Interesting.
No, I
Let's see if
have
we
a
can
2.
figure out. It's right here.
Corner.
Well, net 14 divided by -2 would have been a -7, not a -2.
Yeah.
And then right here, this would have been a -3/2.
Mm-hmm.
So yeah, that kind of made things hard. But otherwise, you understood the process.
Yes.
Just be careful with your positives and negatives and such like that there. All right, homework for this evening. There's a word problem handout that I gave you guys yesterday, correct? That's still due Monday. So I'm not going to be, Kyle, I'm not going to be checking for that tomorrow. Curtis, you won't be here tomorrow. So we're not checking for that tomorrow. We're checking for that Monday. I want to go over that with you live and in person. I don't want to do that on a video recording. However, for homework, page 144. Page 144. And this I will be checking tomorrow. With, I guess, just Everett and Kyla. Page 144, review 5 through 10. Page 144, review 5 through 10. And page 148, in the middle of the page, there's 3 sections on page 148. There's a practice, there's a review, and then there's a review of linear inequalities or something like that. The middle section of page 148, do 1 through 8. The middle of 148, do numbers 1 through 8. Tomorrow we'll be reviewing for the exam. So Curtis, definitely want to watch tomorrow's video, okay, because there's part of the exam review. There's stuff on Monday, which is our main exam review day. There's stuff I won't have time to cover Monday. I'm going to be covering it in tomorrow's lesson. So make sure you watch that. Zach and Rebecca, make sure you watch tomorrow's lesson. Everett will be live, so he doesn't have a choice. He has to be there. Exam is Tuesday. Okay, exam coming up Tuesday. All right, when the bell rings, you'll be dismissed. Have a wonderful day. And Zach, I want credit. I was done before the bell.